Hi students, welcome to Year 9 Science and Unit 2, Our Amazing Earth. This is video number 4, and in this video we're going to focus on the tectonic plates. Your goal in this video is to focus on identifying the main tectonic plates. Now, what's most important when you do this, of course, is look at the local ones. We will present you with the information of the global distribution of these different plates and also their names. But I think it's important as we go through this course, we will narrow our focus onto our more localized region. And so those are the ones that you want to be focusing most intently upon. We've talked about Wagner's idea about continental drift. We've also talked about some of the evidence that supported that idea. Now we've started to look at this mechanism for how continental drift can occur. And we've said that's the theory of plate tectonics. It's a theory that suggests that the crust and upper mantle, which together form the lithosphere, is split into a series of large slabs or plates which can move relative to one another. The important thing is if we have a look at the location and size of these plates on a world map. Now, importantly, they're not all the same size. Not all the same size. And also, we've got issues about their speed and direction. We looked at in the previous slide that they don't all move at the same speed and they don't all move in the same direction. And this is what creates some of the really interesting phenomena that we see around tectonics. So let's have a look at this map. So here's an example of a map showing the major tectonic plates. Now you can see when we were talking previously about our jigsaw fit, if we look at the edges of South America and also Africa, you can kind of get that sense of where these two may have originally come from. And you can see that there is a plate boundary. So the reds here are indicating the plate boundaries. That is where one plate meets another plate. So you can see, for example, the Arabian plate is a very small plate. The Caribbean plate is also a fairly small plate. The Pacific plate's very large. The African plate is very large, and the Eurasian plate itself is also a very large plate. So when we talk about plates, it's kind of hard to get a sense of the fact that some of these are many, multiple times larger than others. What we have been able to do, and what we'll look at later on in this video series, is the fact that we've got a number of different devices that have enabled us to collect information about what is actually happening in terms of the relative motion of one continent to another. So we get a sense, are they moving together? Are they moving apart? Are they moving in the same direction? Are they moving in the same direction at the same speed? And so on. The other thing that's worth looking at this very early stage as we introduce this whole idea of tectonic plates is to pick some of the areas that we know are relatively active tectonically. So, for example, one of the regions in the world that is probably most famous in terms of its earthquake zones are here. So in California, we know that there is some serious concerns around the frequency and magnitude of earthquakes that occur in that area. And you can see just very simple way already, the arrows indicating the direction of motion of the plates in a very broad way are going against one another. So this is two plates that are effectively rubbing against one another. Whereas, for example, if we look down at South America and Africa, you can see that the arrows are actually indicating that the two plates are moving apart from one another. You can also see places such as where India is and the Eurasian plate where they actually are coming together. This coming together creates one of the greatest mountain ranges in the world, the Himalayas. But we'll have a look at some of the phenomena that are associated with these plate boundaries, again, in a slightly later video. At this point, it's useful to have a look at all of these different plates. Most of the plates have been relatively logically named, so you've got a bit of a sense from the name of the plate, the geography of that particular plate, although not all of them are as directly relatable. There's also a few other interesting phenomena that are part of this map, and there are things that we're going to explore in a little bit more detail as we go through this course. So what we want to do is just shift this view across a little bit to put the Australian plate a little bit closer to the centre. And when you look at that, what you'll notice is that Australia is sitting right in the centre of the Australian plate. And this is a really important point because I mentioned on a previous video that Australia tectonically is very stable. We don't have a lot of earthquakes, we don't have a lot of volcanic eruptions, and this is associated with the fact that we are centralized on a plate. Now, sometimes reverberations that occur as our plate interacts with some other neighboring plates, and you can see just at a quick look, we've got quite a number of plate boundaries: the Antarctic plate, the African plate, the Indian plate, the Pacific plate. All of these are interacting with our plate in some way or another. And of course, I didn't mention Eurasia or Philippines. There's a whole lot of stuff that's going on around the Australian plate, but isn't actually happening directly to Australia itself. However, look at one of our close neighbours, New Zealand, and you'll notice that New Zealand's North and South Island are sitting almost bang on a boundary, the boundary between the Australian plate and the Pacific plate. In comparison to Australia, New Zealand is quite tectonically active. We know of certainly some major earthquakes that have occurred in that region, even in the past decade or two. And this is a result of New Zealand's location being right on a plate boundary. In fact, the distribution of earthquakes and volcanoes is highly correlated to these plate boundaries, and they're definitely something that we want to have a look at in future videos. For now, focus on the Australian plate, where Australia is located in that plate, and who or which plates are our closest neighbours and what may be happening tectonically at each of these different regions. To summarise then, the plates themselves are of all different shapes and sizes. Australia sits in the very centre of the Australian plate, and that's why tectonically it's quite stable, not very active. The fact that we are away from some of the plate boundaries does not mean we will never get any tectonic activity, and we know not that long ago, probably relatively, depends how old you are, I guess, for an old bloke like me. The Newcastle earthquake wasn't that long ago, but it may well have been before many of you watching this may have been born. And that was a fairly significant earthquake, but that wasn't an earthquake that occurred as a result of Newcastle sitting on a boundary zone. What it was is more likely to have been a reverberation that went through the plate. So if you're sort of standing on a trampoline, for example, and someone pushes one end of it, you can sort of feel that at the other end where you're standing. That kind of a thing where you're sort of feeling that wave moving across the plate. And certainly that's something that has happened in Australia throughout its history. So we want to concentrate on Australia and its tectonic history, but we also want to look at our nearest neighbours because they are tectonically more active than Australia is, and we want to see if we can use this idea of plate tectonics to help us to explain things like the distribution and the cause of volcanic eruptions and earthquake zones. But we'll have a little bit of a look at that in a future video. Thanks for watching.